In the world of AI development, if software is the recipe and skills are the bakers, then computation is the oven. No matter how good your recipe or bakers are, you can't bake bread without enough ovens. In AI, computation has become the critical cost factor, and it's evolving rapidly. In this video, we'll look at why computation is becoming the new bottleneck, how specialized chips are changing the game, and what this means for businesses deciding where and how to run their AI. Hi, I'm Professor Reza's AI avatar. We've already covered software and skills. Now it's time to turn to the ovens, the computational power behind AI. Early AI models ran on CPUs, the general-purpose processors that power everyday computers. As models grew, GPUs, graphics processing units, became the standard for deep learning due to massive parallelism. Now, the frontier is AI-specific silicon like Google's TPUs and other accelerators tuned for matrix math. By the numbers, as of August 2025, Google Cloud lists TPU v5p at $4.20 per chip hour, on demand in US regions, with its next-gen Trillium at $2.70 per chip hour. Google also notes that a TPU VM can bundle multiple chips, e.g., a V4 host with 4 chips equals $12.88 per hour as an example. These price points highlight how specialized hardware is being priced and packaged for training and inference at scale. It's not just Google. Apple, Tesla, and dozens of startups are developing chips tailored for machine learning. These aren't just faster, they're more energy efficient, which matters when training billion-parameter models. For businesses, this means more choice but also more complexity. Which hardware do you bet on, and who do you trust to supply it? Most organizations can't justify buying and operating their own AI hardware farms. Renting compute by the hour is usually more economical and flexible. Concrete reference points. August 2025. Azure. N D96 ISR H100 V55 8 times H100 lists around $98.32 per hour on demand. AWSEC 2 capacity blocks for ML show an effective rate of $31.46 per hour per P5.48x large instance, approximately $3.93 per H100 hour, in several US regions. Google Cloud TPU View 5Pi is $4.20 per chip hour on demand. To ballpark project costs, a 1,000-hour training run on a single 8 GPU node would be roughly $98,000 on Azure on demand, $31,000 with AWS capacity blocks when available, and $33,000 to $67,000 on Google Cloud, depending on whether you use 8 to 16 TPU v5Pi chips. For small and mid-sized firms, cloud-based computation is often the only viable option. It avoids the capital expense of buying servers, where a single H100 GPU can list around $25,000 to $40,000, and an 8 GPU server can run into the hundreds of thousands once networking and power are included, but introduces ongoing operating costs and potential vendor lock-in. At the extreme end, training frontier-scale models can exceed $100 million in compute. By contrast, solid mid-scale efforts are far cheaper. For example, MosaicML's open-source MPT-7B was trained from scratch on 440 times a 100-40 gigabytes for approximately 9.5 days at an estimated $200,000. These reference points help size your decision. Rent when you need elasticity and speed. Buy only when utilization and scale justify it. Computation is the oven of AI economics. From CPUs to GPUs to TPUs, hardware has evolved to meet rising demand. Businesses now face a critical choice. invest in their own infrastructure, or rent it from cloud providers. Either way, computation is no longer just a technical detail. It's a central part of AI's economic story. As we've seen, software and skills lowered the barriers, but computation is pushing costs upward again. In the final video of this series, we'll talk about the last ingredient: data, the flour that makes AI possible.